Okay, so now we're jumping into the first chapter. And we don't do the first few sections. Some of that's like how do you plot points in a plan. So we generally didn't do those before, so we're not doing them now. That means we're jumping to section 1.4, which is functions. And even, Zach, even 1.4 functions is really repeating anyways. Let's see. So we're going to see how do we determine whether relations are functions. What do we mean by the domains of functions? Use some functions to do some real-world problems, and then evaluate what's called the difference quotients. So a relation, by definition, is a set of ordered pairs. You know, something that relates x to y. So these curly brackets here, those are set brackets. So this is just an example. I made up 3 points. That would be a relation. Any old set, a finite set, right? It's got the curly brackets, and you can list all the points. That's a relation. Now, if you have an equation that has x and y in it, then you can't write down all the ordered pairs that make up that equation. Right? You're going to get an infinite number of points. But still, that is a relation, because it does give you some kind of a relationship between x and y. Good. Now, a function is a particular kind of relation where each x value only has one y value. So, for example, that set of ordered pairs that I wrote down, because you can look and see that the x value, like 1, is associated, x equals 1 is associated with y is 2. Right? X is 2, y is 3, x is 3, y is 4. There's no place where you try to like make 2 different y values go with the same x value. Usually when you're looking at a set of ordered pairs, you just see, do you have any repeated x values? If you do, it's not going to be a function. If you're looking at an equation, this particular equation that we use, that's a relation. It's actually not a function. And you can see that it's not a function if you solve for y. Right? If I solve that for y, subtract x squared from both sides, then I take the square root of both sides. When you take a square root, you've got to put a plus and a minus in front, which means that for every x value that I put in, how many y values am I going to get? 2. Except for 1. They're actually 2. If you put in 4 or 2 or negative 2, then you just get one answer, 0. But for all the rest, like if I put in x equals 0, then 4 minus 0 is 4. The square root of 4 is 2, plus 2 minus 2. There you go. 2 y values, 1 x values. So normally when you're looking at an equation, if you see the plus or minus, or even if you see raised to an even power, you know that is not going to be a function.
Could you also just always solve y?
Sure. It's just that if I had this problem, I wouldn't bother solving because I know what's going to happen in the last step. I'm going to put a plus or minus in there. But if you want to, that would work. Good. Let me know if you got any fun. Slow down. Okay, so looking at this one, first we're going to look at a mapping diagram. These are all the x values in the domain. These are the y values. Would you say that this represents a function? Why not?
Because they're repeating exercises for y values for negative
For which value of x?
-1.
Yeah. If x equals -1, -1 goes to 3, and it also goes to 4. It means you have two ordered pairs. -1, 3, and -1, 4. So that's not a function. Not a function. How about that table of values? Does that look like a function?
Yes.
Okay. Notice the x values. No repeats. So, no repeats. So we say not a function. Or sorry, yes function. And most of these examples that I'm doing, like just example 1, if you go to the book, there's a different example 1, and then there's like a check understanding right underneath. I'm doing the check understanding so that you have the other example that's above. It's got everything worked out. If you want to like have two worked out things, you've got two worked out things. Unlike Algebra 2, there's usually not a lot of time in this class for me to do like, here's an example, now you try one, and I'll go around and check everything. We usually just have way too much stuff to get through, but we don't really have time to do that. Go ahead. So just looking at these equations, which would you say represents a function and which is not a function?
A is a function, A is not.
How do you know that A is not a function?
Because of
Y squared.
Right? Because of this squared, not a function. Because on the last step to solve for y, you will take the square root and you will introduce plus or minus. So you're going to say not a function. Right? But look at b, y is raised to the first power. I mean, I can solve that, right? That would be y equals 4x squared minus 36. Right? I will only give one y value for every x now. So that's a function. So the only thing you're looking at is what is the exponent. So this is a function. Now, what if this problem was x to the 4th plus y to the 4th equals 8? Would it be a function? No, because a fourth root also, when you take the fourth root, it makes a plus or a minus. What if it was x to the 3rd plus y to the 3rd?
That would be a function.
That would be a function. Right? So a to be raised to an odd power, you don't have the plus or minus.
So you said it's raised to an odd number, then it is a function?
Yeah, just like this one here, right? This y is raised to the first power, which is y. That's why it's a function. We're good? Okay, the function notation, which you've used over and over again, right, is f of x. And generally, y equals f of x. We think of those as interchangeable with each other, as they are. The way you read this is y equals f of x. And the parentheses there does not mean multiplication. You never want to think like there's some multiplying going on in there. This is a function notation. It's telling you, y is a function of x. Y depends on x. See how I wrote this here? Y is a function of x. The value of y depends on x. Right? Because of that, you would call x's independent variable. You're going to plug in the x that you choose. And then you'll calculate the y. So the value of y will depend on what you plug in for x. So independent variable, dependent variable. Even in your calculator, right, if you go to the table set, here, and independent, dependent, that's what they mean. X values, y values. Okay. All right, guys. So how do we evaluate a function for a particular value? for example, in this one it says f of x is 10 minus 3x squared. What does it mean to say f of 2? Plug in 2 for x, right? Whatever is in place of the x here, it's got to go in place of the x there. So for a, you would say f of 2 equals 10 minus 3 times 2 squared, which is 10 minus 12, which is -2. How about f of -4? What will that be? Who's got an answer?
-38.
-38. Who else has that?
Yeah, I think that's right.
The thing you want to be careful of, and this is where we always make mistakes, is that when you plug in this -4 for x, right? -4 squared will be +16. Don't put it in the calculator and let the calculator tell you it's -16 because it's not. That's why you need parentheses when you put it in. But we tend to make a lot of mistakes when we have squares involved, when we have negative values of x, and when we have a minus in there too. So all those things tend to lead to the wrong answer. But 10 minus 3 times -4 squared, right? Which is 10 minus 3 times 16, which is -48, so -30. Right. How would we find f of, now there's not a number in the parentheses, f of x minus 1?
You
Like x minus 1.
Just replace, right, wherever is the x in this expression, you're going to take the whole x minus 1 and put it into that place. Right? So it'll be f of x minus 1 equals 10 minus x minus 1 squared. Yeah, I messed up with it. Minus 3 x minus 1 squared. So even it doesn't matter that the thing we're plugging in has also got an x in it. Okay, just take that whole thing and put it in place. Okay, now what am I going to have to do to simplify that?
What?
Yeah, first you're going to have to deal with the x minus 1 squared, right? Which is a FOIL. It's not x squared minus 1. It's x minus 1 times x minus 1, which is 10 minus 3 times x squared minus 2x plus 1. Right, that is a FOIL. And then we have to do 10 minus 3x squared plus 6x minus 3. And then you got to combine my terms, which are so 10 minus 3. So this is negative 3x squared plus 6x plus 7. You know, generally, you would write it in standard form with the highest power to the left and decreasing order. Now, by the end of the lesson today, the last thing we did, the last thing was in our objectives, was called a difference quotient. And when we get to the difference quotient, we're going to have to do this evaluating of a function. You okay here? Bart? You okay? Okay. We're going to do this now with the same function, 10 minus 3x squared. How would we find f of x plus h? We struggle with this one over and over and over again. And we do it a little bit at the beginning of the class, and it's actually like the last chapter. We do this all the time. How would I find f of x plus h?
For every x, you add h.
Okay, meaning plug that in the place of x. Right? It'll look like this. F of x plus h equals 10 minus 3 times x plus h squared. Right? Whatever's in the parentheses, just replace the x. It's completely. And then you would have to simplify. That would be 10 minus 3 times x squared plus 2xh plus h squared. Right? Because we're FOIL, it's a square. It's x squared plus h squared. That's this one and this one. Plus 2 times the inner product. 2 times xh. Okay. And now we still have to do this. 10 minus 3x squared minus 6xh minus 3h squared. Yeah, I'll leave it like that just because all these things, we can move the 10 to the back, but because it's got both x's and h's and that's a little bit different. Now, I'll say negative 3x squared minus 6xh minus 3h squared. That would probably be more proper in the standard form because it's still decreasing order of the powers of x. Squared, first power, both of these are constants with respect to x. So we'll see that again by the end. Okay, here's another thing that we tend to struggle with a little bit here. It's called a piecewise defined function. A piecewise function has different definitions depending on what is the domain of x. I mean, where are you on the x-axis that you're trying to evaluate this thing? These here are telling you where you are on the x-axis. They are domain statements. Like this is telling you when the x values are less than 0, use that formula. When the x values are greater than or equal to 0, use that formula. It's called a piecewise function. So, for example, f of negative 2. Which formula would I use?
There's x squared plus 1.
Right? Well, negative 2 is less than 0, so use that one. Negative 2 squared plus 1. How about f of 2? Which formula I can use?
X minus 1.
So f of 2, 2 is greater than or equal to 0, so use this formula. How about f of 3?
X minus 1.
X minus 1, right? That's still up here, so we go 3 minus 1 equals 2. That's called a piecewise function. Remember, these are called, this is the domain. Remember, we're going to get to domain in a second, but domain means x values. Okay, what do I mean by 0? All right, when you're given a function like this, what does it mean to say find the zeros? It means to say this. Find all the x values that make the function equal 0. So if you substitute here for the f of x, make it 0. Not f of 0. Make the whole thing 0. That's what it means to find the zeros. So plug in f of x equals 0, solve it. This is not a challenging problem. X squared equals 16. X equals plus or minus 4. Don't forget the plus or minus. I would say, usually like on a test question like that, about half of you will forget the plus or minus. Plus or minus. So domain. Again, and domain is another concept that we struggle with, and it's pretty important. Like when you get to calculus, you got to have a good grasp of what you mean by domain. And it's not once you get it, it's easy. It's very easy. Like we tend to somehow we have a hard time like getting over the hill and seeing that. not just this lesson, I think the next one we do more of like looking at domain from graphs. Maybe when you see all of it together, it'll start to make some sense. What do we mean by domain? Generally, you think of domain as x values, right? So if you had a finite set of points, you would just grab all the x values, put them in set brackets, there's your domain. When you have an equation represents an infinite number of points. There's no way you're going to be able to write down all the x values in one set. So we're going to have to use some kind of interval notation or inequalities to represent where the x values are that the domain includes. Yeah, I like to think domain is telling you what can I plug in for x. What am I allowed to plug in? And we'll see on the next slide what you can't plug in. When is it that domain is limited? In this book, when they talk about it for an equation, they're calling it an implied domain. That's why I put it in. I don't think he did that in his last book. Implied domain. So let's say if we look at this first set of ordered pairs here, how would I find the domain? Write down all the x values, right? So for A, I would make myself some set brackets and just write down the x values. -2, -1, 0, 1, 2. I just write down the x values. Now, for the rest of these, we've got equations or formulas. If you look at the letter B, g of x equals 3 minus x. Can we plug in any value of x and have it be defined, have g of x be defined? Or is there some value of x we have to make sure not to plug in?
Yeah, like
You can't plug in a 3 because why?
3. Is it a big function?
Right, you'd be dividing by 0. You're not allowed to do that. So the first thing you look for is divide by 0 situations. In that case, the way you usually say it, you could say like all real numbers except for 3, or generally you just say x does not equal 3. It's implied if you say that. It means all the other numbers, just x does not equal 3. Now, look at this next one. The circumference of a circle, we know the formula, 2 pi r. R is like the x of this equation. So the domain is what values can I plug in for r? So let's see. In that formula right there, is there any dividing going on that I might divide by 0? Is there any square roots that I could take the square root of the negative number? So would you think that the domain is all real numbers?
Yeah.
But would it make sense for the radius to be negative?
No.
Radiuses are always positive. So this, in the context of the problem, we know we can only plug in positive radii, right? You wouldn't even put in 0, because you wouldn't have a circle if it had a 0 radius. So that one we'd have to say C, R is greater than 0. And it's not because of the math, it's just because of the problem that we're dealing with. The letter D, right? What is it that we have to watch out for in letter D? We can't, go ahead, Zach. Zach? I say Zach. What do we have to be careful about when we plug in values of x here? Radical, Michaela? Okay, we only want real numbers here, right? So we have to make sure we don't make this the square root of a negative number. Right? How are we going to do that?
X cannot be greater than or less than 16.
Generally, what you do, take what's inside the radical, x minus 16, and set it greater than or equal to 0. Right? We know whatever's inside has to be greater than or equal to 0 in order for this thing not to be undefined. Now solve that for x. X equals, so x is greater than or equal to 16. That's the domain. Now we did this was a square root, right? Because it doesn't have anything, an index there. But if it was a 4th root or a 6th root or any of them, you'd have the same thing. We have to take what's inside, set it greater than or equal to 0, solve. Now, when we were in Algebra 2, there was actually one other function that we couldn't just plug in any old value for x. Do you remember which other function that we studied had a restricted domain? Remember which function had a graph that looks like this? Starts with an L. Logarithm. Right? You can't remember. You cannot take the logarithm of 0, and you can't take the logarithm of a negative number. They don't give us that in these problems, but that was actually the other one that we dealt with in Algebra 2, where sometimes you've got to worry about what you're going to plug in. But remember, you get to pick x values. When you're graphing a function, first thing you do is plot points. You got to know what points can I plug in. Well, this tells you, for a logarithm, don't plug in any negative values, don't plug in 0. It would not work. Okay, here's our real world problem. Write this formula. This is example 8. And I will see, 1 4. It's 1 4. 1 4.
It doesn't say sweet.
This is so.
But if you read the problem, which is always a good place to start, the problem says you work in the marketing department of a soft drink company and are experimenting with a new can with iced tea that is slightly narrower and taller than a standard can. For your experimental can, the ratio of the height to the radius is 4. Write the volume of the can as a function of the radius. Write the volume of the can as a function of the height. So first is the volume of a cylinder has a formula. Right? Pi r squared h. But that's the starting point. The volume is pi r squared h. What does pi r squared represent? Pi r squared is the area of the circle. So that's telling me what's the area of the base right there. And then the h is the height of the can. So if you do the area of the circle, you multiply times the height, you get the volume of the whole cylinder. But in this writing of the formula, volume is a function of both radius and height, right? Because both r and h can change, it's a function of both. Yeah, go ahead. What's that? There's tissue there, there's tissue there. What they want us to do is somehow come up with this where its volume is a function of only r, that there's no h on the right-hand side. Well, how can we get rid of the h? What other piece of information did they give us? It said that the ratio of height to the radius is 4. So if I start with the volume equals pi r squared h, and then I know that the h over r equals 4. If I solve that for h, then I can plug in for h in the formula, and I won't have h anymore, it'll just be r. Solve this for h. h equals 4r. Now, put that in the place of h here, put 4r. So we go. Volume equals pi r squared times 4r. So volume equals 4 pi times r squared. Times r to the third. So now, pi is a constant, right? That's not a change, it's not a variable. The only variable now that volume is a function of is r. If you know the r, you plug it in, you calculate the volume. How would I do the same thing, a similar thing, and make it a function of h? Does r equal 4h? I mean, we need to solve that same equation for r now. so we can substitute for r. So let's see, if h over r
R
equals 4,
R equals
then r equals
H over
h over 4. Okay, and now that's what you want to put in the place of r. So volume equals pi times h over 4 squared times h. Volume equals pi over 16 times h to the third. So in this case, volume is a function of h. If you tell me the h, I can tell you the volume. You don't need to know the radius. I think there'll be one question in the homework which is pretty similar to that. Write something as a function by doing a substitution. Okay? Okay? Right, this problem, again, another real world problem. The thing you got to understand about a lot of the, because I know that again, out of 29 students that are still in here, there's a fair number that will hardly touch the word problems when you get to them. Because that's always the way it is. But a lot of times these word problems are really nothing more than doing what you've already done. They've wrapped a few words around at the beginning and the end, but in the end it's really a pretty basic application of what we did already. In this problem in particular, let's read it. A batter hits a baseball at a point 3 feet above the ground at a velocity of 100 feet per second at an angle of 45 degrees. Okay, that's pretty complicated. The path of the baseball is given by this function. So they've given us a function with a function notation, where f of x is the height of the baseball and x is the horizontal distance from home plate in feet. Will the baseball clear a 10-foot fence which is located 300 feet from home plate? Okay, what are they asking you to do? They want to know what's the height 300 feet from the fence. Okay, what are you going to do with that 300? What does 300 represent in this function? X is the horizontal distance from home plate. So that's what that is. That 300 is the x value. They're asking you to do f of 300. By that point, you've already done problems where they gave the equation and said, find f of this, find f of that. That's all you're doing. Just plug in 300 for x. And in this case, that'll be negative 0.0032 x squared. Oh. Okay. Put in 300. And if you do all the number crunching there, it is 15. So the question was not how high is the ball 300 feet from the plate. The question was, is it going to clear a 10-foot fence? Is it going to clear a 10-foot fence? Sure. 15 is greater than or equal to 10. So yes, clears the fence. Which leads us to one more thing. Okay?
Presentation.
You good? All right, good. Difference quotient, right? This is a difference quotient. What does the word difference mean in math? Subtraction. What does the word quotient mean in math? Divide. So there you go. This thing has a subtraction in the numerator, and then it's a divide. H does not equal 0. Why does H not equal 0?
You guys are
Because they're making function divide by 0.
You'd be divided by 0, that would be undefined, right? So when you evaluate a difference quotient, you're going to be given a function, and you're going to have to find f of x plus h, just like we did in that prior example. And then you're going to subtract the f of x, and you're going to divide by h. But usually where we get stumped on this, it's in this part right here, just finding f of x plus h. That's usually where we make a mistake. That difference quotient. So here's an example of finding the difference quotient. Here's the function, f of x is x squared plus 2x minus 3. So in order to find the difference quotient, the first thing I need to find is f of x plus h. How will I find f of x plus h?
Well, you did that.
Okay, what would that look like?
X plus h squared
X plus h squared
plus 2 times x
plus 2 times x plus h
minus 3.
minus 3. See that, all we were taking that and we put it into place there and there. Don't forget the negative 3. Okay, now you have to simplify. Again, x plus h squared will be x squared plus h squared plus 2x each plus 2x plus 2h minus 3. I FOILed the x plus h times x plus h. I distributed the 2, and I still have the minus 3. Okay, the next step, subtract f of x. Okay, so I'm going to do this like f of x plus h minus f of x. So subtract x squared plus 2x minus 3. Okay, now see what happens. X squared minus x squared, cancel. 2xh plus h squared. 2x minus 2x, cancel. Plus 2h. And minus 3 minus negative 3, 0. Cancel. When you do this in the difference quotient, every term that doesn't have an h in it will cancel. Every term. Always. Your f of x will always cancel with something that was in the f of x plus h. So this is our f of x plus h. Oops. Now we divide by h. Okay, what would that be? Right? So notice, if you need to do it this way, you could write it like 2xh over h plus h squared over h plus 2h over h. Right? The h's cancel. This h cancels with one of those, and these h's cancel. So what's left is 2x plus h plus 2. And you can do any way you want. You know, I always line it up like this. And if you're making a lot of mistakes doing it your way, do not try to do it this way. Okay, when we get to the very end, I mean, what's the name of your textbook? Pre-calculus with
Limits.
limits. At the end of the class, we'll learn what a limit is, and we'll take the limit of that expression as h approaches 0. Remember, h cannot equal 0. But we can say, what value will the whole expression approach when the h is approaching 0? 2x plus 2. And that, in calculus, is called the derivative. So that's what we did. That's the homework. And there is one problem here, the 67, which, again, it's odd number. I think there's an answer in the back. Probably not the work. I think if you go to the larsonprecalculus.com, you probably could get the work too. But you're going to need two things to do that problem. It's a little more of a challenging problem. You're going to have to use slope. Right? Slope, y2 minus y1 over x2 minus x1. I'm not going to tell you how to use this, but you'll definitely need that. And you'll need to know the formula for the area of the triangle. 1/2 feet each. So I know it's not gonna come to you instantly, you're gonna have to think a little bit, right? Think hard.